to do before we build the app that I forgot to talk about real quick. So yeah, we'll see. I'm expecting you guys to be slightly confused what is going on here. This should look strange. It should be spooky that I'm just updating this variable and the view redraws based on the state of that variable. It's very strange. It took me a while to start thinking in the declarative UI way. So yeah, don't worry if this sounds really strange, if it looks really strange, it'll get better. So we'll come back, we'll build a little app. I wanted to show one other thing with our box and with our coin here. So we'll make it, here, we want the coin box. Oh, come on. No. Okay. So yeah, we'll make a couple of changes here. So I want this to be a box now that can actually just hold a coin. We don't need this generic parameter. I want to be able to shake it and randomize a coin flip in a bit here. So we don't need this anymore. Oh, I removed the coin as well. Let's create a new one. Okay, so we have a box that takes a coin, and let's say we have a shake function here. Oh, sorry. Let's say sorry. What was I going to do here? Yeah. Let's not do it with the box. So we have a coin. I want to be able to, so we have heads, tails, and we have a property for what is up. So is it heads or tails? So we'll have a string here that either says heads or tails. Okay, so I want to be able to flip the string, this coin. Let's have a coin property. And we'll say heads is up. We'll learn a slightly better way for not using a string here in a little bit. But yeah, so we have this coin. And so we've seen that we could have a box that can hold a variable, that can flip the coin. What about a function that can flip the coin for me? So flip coin. So how would we do something like this? And then, so yeah, we can kind of just, there's some people prefer function signatures like this, flip coin and then no parameter name, or we could do something like this, flip and then have the name of the parameter there. So we have this flip coin function. So let's call it flip coin. We have our coin here. Okay, so it goes in, and so maybe we don't do a string here. Maybe let's do an integer. Let's say let's make a property is heads up Boolean. I think that's a little bit easier. So maybe it starts off as heads up. So all right, so we have a coin. It has a property of what's up. We have a tails. We have a number for tails and a something that's on the head. I'm calling flip coin, and then I'm gonna be curious what is up on the coin, which direction is facing up. So we've introduced this one property here that is a little bit different from the other ones. So heads and tails don't really change, right? So if you're thinking about heads or tails on a coin, so they will never change on that same coin. We might have a coin with a different heads or tails, but those will not change. Now we're recording something about the coin's position on the coin. So this is not a physical trait of the coin, but it's a trait of the coin interacting with the environment. So maybe one could argue maybe this is not a good property to put on there because the coin doesn't necessarily keep the information of what's facing up. But like for this demonstration, I think it makes sense to just put it on there. All right, so coins are value types. If I put the coin inside this function, what is going to happen if I try to flip it? So one thing we can do is to decide what is up or down. We can randomize a Boolean and decide what is up or down. So let's do that first. New here. So we have a new is heads up here, and then we'll create a random Boolean. So now is heads up is sometimes true, sometimes false, and I want to assign this new state of the coin to my coin. What problems am I going to run into if I try to do that? So I'm passing in the coin, and I'm going to try to, in this function, affect if the coin is up or down. What issues am I going to run into? Yeah.
The state issue that we cannot change a struct state.
Okay. Yes. Very good. So let's try what happens. So let's have our coin, and then we have is heads up. Let's try to assign that. Okay. So we'll get some cryptic compile time errors here that will make sense of all of them here. So this might be an unexpected compile time error to get here. So we know that. So we have a coin. Coins are value types. We're expecting that it says something like, oh, self is immutable. But what we get here is cannot assign property. Coin is a let constant. What does this mean? So coin here is the coin that we passed in. When we have a function and we're passing in a value type, those parameters are they are passed by value. So they are the value is passed on, but not the object. So if we had a class here, we would pass the reference, and we can affect the insides of it. But here, the value of the coin is passed. So this is you can almost imagine this as you're on the phone with your mom, and you have a coin, and you're asking her to flip a coin. So what would you do? How would you tell your mom to? So you have this coin. Maybe it's facing heads up. How could you, while talking to your mom on the phone, have her flip a coin and affect the coin that you have in your hand? So we'll have to do some funny things to have this happen, right? So what's one way that we have so any solution is accepted here. So that is physically possible. So we have a coin that is heads up in our hand, and we're asking your mom to flip the coin, and then we want our coin to be affected by this. So what could we do? We're on the phone. And so this is kind of what I'm trying to simulate here with this function. So we have to pass by value, right? So we have the information here. We're not going to pass the physical coin through the phone, right? So we're going to have to pass by value the information that we have here. So maybe one instruction that we could give to the person that we're talking on the phone is, so I have a quarter. It is currently heads up. Could you get a quarter, please, and flip it heads up? So we're passing the value of the coin over the phone line. Does that make sense? Okay. So now we have the state that your mom might have to be in to flip this coin. So she's going to flip the coin, and maybe it says now tails. So her coin that was passed by value now shows tails. Ours still shows heads, right? So what do we have to do to make ours be the same thing?
We'll just flip it like that.
We flip ours, right? Yeah, so she'll tell us the new value, and we'll flip it. So this is exactly what we have to do when we're dealing with value types and passing them into functions. So the coin will be passed by value. So we can flip this thing. It is immutable here. So we have a coin that the actual coin we can't. This is just the information of the coin. So we can't change the information of the coin. So first thing we said, get a coin. So the person on the other side of the phone is going to get a coin. So I'm going to call it internal coin. Internal coin. And what do we set this internal coin to? We're setting it to the state of this coin, right? So we're passing by value. So the internal coin takes on the information of this coin. So we didn't take the original coin and assign it to this internal coin. What we did was we took the coin, we passed by value this information, and now we're assigning that information to our internal coin. Does that make sense? So those are the exact same steps we did on the phone. Okay, now we can flip the coin. We're randomizing something. And then our internal coin, we are updating the isHeads property. And so this sounds like something that should be illegal. So we're saying we can't, so we're dealing with value types. We shouldn't be able to update the value type. We are not updating the value type. So we're what is actually happening here is the following. So we can think about it this way. Okay, so these two statements are equivalent, but this one is just a little bit nicer to read. It looks like we're changing an internal property on our coin, but we really are not. And I can demonstrate that this is true by turning isHeads up into a constant. So if I turn, oh sorry, not isHeads up into a constant, not that one. Sorry. Sorry, by turning this one into a constant. The internal coin. If I'm turning the internal coin into a constant, so if the coin was a constant, and I'm actually changing, so if I still have the same property, it says that isHeads up is a variable. So I should be able to change properties on my internal coin if it is a variable, right? So if I was dealing with the same instance, so if I was actually changing a property on internal coin, since is heads up is a variable, I should be able to do this. But since internal coin is a constant, what is actually happening is the following here. So we are trying to assign a new value to our internal coin. We can't assign a new value to our internal coin because our internal coin is a constant. So since this is a variable, I can assign a new coin, a fully new coin to internal coin, and this is what's happening. This is what's happening here. So, is that again?
When you change the internal thing to a constant,
Yes.
you can still change that. No, like one.
I cannot change that.
Oh, okay. I didn't see that.
Yeah. So yeah, by updating a property here, we are getting a new coin. So if we are so we will never update heads. So I think that's a good constant to choose here. We will never update tails. We have properties on coin that it is very convenient if we could get a new copy of the coin with just this property changed. And by making properties on the coin, marking them as variable, that is what's going on behind the scenes. So we're saying, hey, I want a coin that has heads up changed. So give me a new coin that has this new property, and I'm going to assign that to this one here. So that's what is happening when we have a variable on a coin. When we have a variable on a struct, and we are changing that variable. We're getting a new coin. We're getting a new variable. So we can't do that in our content view. So here, even though this is a variable, when we're trying to update it, we would get a new content view, but the place where this is stored is immutable. So wherever SwiftUI is holding onto our content view, it cannot be mutated. So that's why the like convenient way of pretending updating a property by changing one of its properties does not work. Does that make sense? So even though it looks like we can update a property on a coin, we cannot. So updating this variable will result in a new instance of coin being assigned to the variable that holds it. So the result of this is if the coin is assigned to a constant, even though is heads up is a variable, we cannot update is heads up, because we would be getting a new instance. Does that make sense? So I almost wish this wasn't possible, because it looks like we can change properties on a struct. But so structs are immutable. It looks like we can, but we cannot. So yeah, actually, so maybe this is a little bit, so I'll put this back in a second. I think this is maybe a little bit easier to see this way. So we have coin. We want to update is heads up. So we'll do double dot random. Oh, not double, bool. Okay. So because coin, we're passing it by value. So we don't have, so if you're on the phone with your mom, she has not gotten a new coin yet. at this point. So we're just dealing with the information of the coin. So we won't be able to do this. Does that make sense? So value types are not mutable, even though they might have variables on them. If those variables update, we get a new instance. So it's a small nuance, but very important for understanding what is going on. So we're not changing the instance that we get. We get a new We get a new instance. Does that make sense? Yeah.
Well, I guess in this case, like, since is heads up is true, wouldn't that mean like you're changing the entire struct?
Yes. So here we would be changing the entire struct, which we cannot because we passed by value. So this would be, if we're on the phone with your mom, this would be your mom trying to update your coin, flipping your coin. She cannot. She just has the information of the coin. Does that make sense? Okay. So yeah. Just making sure that everyone, yep.
So she needs a completely new coin.
New coin. So let's go through the steps again. So new coin. We're going to transfer the coin's information over the phone so she can flip it to the right direction. So we have a new coin. New coin is flipped. So we're flipping new coin. So how do we relay the information back? She will tell us about it, right? So she will tell us the new information. How do we do that? By value. Again, we're passing by value. How do we pass by value? We could return. So we can return the new coin. And then now we can update our coin. And then this will have to be a variable again, because coin was a constant. Okay, so we did the impossible. We were on the phone, and someone on the other end of the phone flipped a coin for us, and it affected our coin. So that's the hoops we have to jump through with value types. So I mentioned this in the last lecture. The benefit of all of this is we have complete thread safety. So we don't have to worry about multiple things happening at the same time and different states affecting, coming together, and we have different states that are inconsistent. So this looks funny. It looks like a funny dance to have to go through to flip a coin, but the nice thing is there's no way that another thread somehow flipped this coin also, because in the time that we flipped this, if we call flip coin and we pass this coin to this function, by the time this function has executed, has flipped the coin, we will get the exact information that was created here, and we have it assigned. So there's no place where some other thread could have meddled with us. So the nice thing about these immutable types, these value types, is like 99% of all concurrency issues just disappear, which is very nice. There are some little issues that we have to figure out, like how do we have someone on the phone flip a coin for us, but it's possible by passing by value. Does that make sense? Okay, yeah.
Could you get these things, or would you get issues with classes then? If you were
Say it again, sorry.
Or would you get issues with like classes then?
Yeah, so like could we, so we could, I don't know if, I also wanted to, let's do this real quick. So I'm pretty sure I could simulate this real quick, 1 second. Let's create a class coin. So I guess maybe let's do we have a coin, let's create a die. Oh. So we have up again. So here, let's have up, and that's an integer from 0 to 6. So this is a class. Let's have a function that flips, that rolls the die, maybe. We'll pass in the die. Wait, here we need an initializer. Let's start with 1. Okay, so here we don't have these issues. We pass in a die by reference. What's up? We are going to randomize an integer, pass in a range. Here we go. So 1 through 6. So we are randomly picking an integer from 1 through 6. It'll be assigned. Let's create a die. So I guess it starts off as 1. Here, let's actually create the initializer. Okay, so we're gonna call. Let's move this up. We're gonna call the roll function on the die. And then, so we'll print out. We'll print out what the, oh, I guess let's print it out. We'll print out what's up. Okay, so let's see. So we have 3. Let's call this a couple of times. 5, 6. So we didn't have to jump through these hoops, but by the time, so if this takes a long time, whatever we did here might have changed. So one way that we could simulate that, let me see, I'm pretty sure that we can simulate that real quick. 1 second. I think this should work. So don't worry what we're doing. A lot of what I'm now doing, it's just to demonstrate the point that something else can meddle with it. We should be able to, so yeah, we'll see a lot of this a little bit later. 1 second. I'll explain what I'm doing in a second. I just want to make sure that I can actually simulate this. And then, again, I'll explain what I'm doing, but we will cover this a little bit later. Okay, so we now have a die roll that takes a second. So we are rolling this function will take a second to execute, and once that has happened, so we have our die. We're going to roll the die, and then we're going to print what's up. Okay, so I'm going to execute that. And then I guess, I will print what the die roll is inside the function. Okay, so it'll print what's inside the function, and then we'll print outside. So those two should match. So it takes a second now. Takes a little bit longer than a second. What's going on? Okay, I might have to do a tricky thing here. Maybe we have to do this. Say again, sorry. So we're not getting to the end here. Okay, let's do this in a project. I think it doesn't like the async there. 1 second. New project. Okay, so we'll have a die. We have a die. We have here. Let's copy all of this over. Okay, so we have a die. we have, so we'll create a class die roller that has this function here. Actually, I don't think I need that. Sorry. It's taking a little bit longer than I was hoping, but I think we should be able to demonstrate this. 1 second. So let's create a button. When we press this button, we are rolling the die. And we are, oh, so the function can be outside, sorry. Okay, we can take this die. We'll roll the die, and this should work. Okay, 1 second. Here we go. Okay, so same thing. Now we're just in a we don't need this. We're in an actual app. I think there's something not quite working with things that take a little bit longer. The async. I'll explain that in a second. So we have a button that says roll, and then we have in our console down here, we're printing inside function, and then I guess we should also print what's afterwards. Okay, so let's try that again. Okay, so we're rolling. Inside function says 3, after the function says 3 as well. So this is expected. So nothing is messing with our die. So now let's move the die to a place where we can affect it with another button. So let's create another button. Yeah. So, and here I'm just going to call this one mess with die. Okay. So here we take the die and we'll change it to -10. And then I'll give myself a little bit more time than 1 second. Let's do 2 seconds. Okay, so I'm going to roll the die. It was 3. I'm going to mess with the die. And so it is the die that the die now shows 10. Does that make sense? So I'm rolling the die. If I'm not interfering with it, it is 3. If I roll the die, now I mess with the die, we have -10. So the function that rolls the die takes the die as an argument. While this function was being called, some other thread interfered with it. So this is impossible where we have the value types. So here, we're calling the function, we're passing the coin by value. So we are giving the information of the coin to the person on the other end of the phone. They get a coin, they have it oriented the same way. Now they're flipping it. It lands whatever direction they want, or whatever direction it falls. Now they're returning the coin to us. So they're passing the information of the coin by value. So the flip function returns, we get the value of the coin that was flipped here. So no way to interfere with the coin flip. So this is what this function call looks like for a struct. This is what that function call looks like with a same thing here. We could assign it as well with a class. So from the outside we can't tell the difference. but because the die is a reference type, while we are flipping it, something else could meddle with it. Does that make sense? So we created a race condition. So two things modified the same thing. This is impossible with value types. You had a question?
Yeah, so I guess in Swift, if we were like to try to have some sort of data, like an authentication stuff,
Uh-huh.
would it be smarter to store that in a struct? That way it's, let's say, we're not, we don't have a race condition.
Yes. So the suggestion that we're given by the creators of Swift is we're always supposed to start, whenever we're creating a new thing, start with a struct. So if start with a struct, start with a value type, and then if you have to have reference type characteristics with the thing that you're creating, then be very careful to make that switch. So do I really need to be able to affect the insides of this? If the answer to that is yes, then go ahead and make the change. But at that point, it's up to you to manage our race conditions responsibly. We'll cover how to do all of that later. But yeah, so the thing I wanted to show here is value types are thread safe. You get what you, and that's the same thing that I was trying to show last week with the house. Even if it's very inefficient, and so whenever you're introducing safety, so thread safety, there's some extra overhead, it's going to be a little bit slower. Passing the thing by value is less efficient than passing a pointer and having something be meddled and like meddling with something there. So this all comes at a little bit of a cost, but the benefit is we don't have to. One of the most difficult things of programming, which is concurrency, we don't have to touch. So if we're using reference types, we have to worry about thread safety. With value types, all of that goes away, which is very nice. Same thing. So if other languages give you this choice that you can make something immutable, I would advise go that route. Whenever you can, make things immutable. If it doesn't have to be able to be changed, don't let it get changed. It's a very nice way to control for meddling. Yeah. Any questions there? Does this make sense? So yeah. Since we built this, so thank you for that question. So we built this die roller because of a great question. I just want to make sure that I'm not just giving you something that is not legible to you guys. So let's go through what it does. So our roll function, we're still throwing up a coin. That hasn't changed. So we're changing. I guess the die. We're rolling the die. So nothing has changed there. For integers, we have this nice random function where we can pass in a range. We'll see ranges later as well. So the int random function takes a value from 1 through 6 in this case, and it's going to spit one out that is within that range, which is super convenient. So then what does this thing do? So here we have some exception handling that I'm ignoring, so I don't want to deal with it. And then this await means it's a very smart sleep. So if you have sleep for a processor, it normally means do nothing, but nothing else can happen at the same time. So this await just kind of suspends whatever's going on. So we're saying we're sleeping right now, but like other things can happen. So for 2 seconds, so we're passing in 2 million nanoseconds here. So for two seconds, this function is just going to do nothing, but it's not going to block anything, which is important because we're going to mess with something at the same time. And then this async means that this function has this capability of just doing nothing for a while and letting other people do something. Probably halfway through the semester, we'll talk more about this. All of this will make sense halfway through the semester. So we're rolling the die, and we're kind of awaiting whatever's happening without blocking anything. So we're not going to block the UI. And then if at that same time we are messing with the button. We are messing with a die. So we have the button that just changes the value to negative 10. So we have the same button. We have the same die here, here, and here. So this can happen whenever we want to. So if this is still sleeping here, we've already flipped the die, or we've already rolled the die. We're just now waiting for 2 seconds. So whenever we're pressing this mess with die button, we're going to change this die to this value. So this is where another thread. So we're sleeping. We got the die, but we're waiting for this thing to return. Another thread can mess with it. And yeah, so we're at the end of class. Thanks for coming, and I'll see you guys next week. I'm here for questions if you haven't.